So this is the second part of the section. Now think about that. How are we going to solve this problem? Remember that's what we did? We have equal bases, that means we have equal exponents. But do I have equal bases?
No.
No. So in this case, remember there's another rule. The rule says if you have x equal y, that means log x equal log y, x equal y, log x equal log to the y. Both sides work. If you have log x log y, that means x equal y. So that means in this case, you can use take log here and take log here on the other side. 2 it's minus 2. X plus 1. That was the next step. That's how we're going to solve
The exponent from the log.
from the log. But be careful when you put the exponents from the log, put parentheses here because that means everything you put it here when you multiply the log is going to be distributed. It's going to be 3 x minus 2 log the 2 equal 2x plus 1 log 3. Now tell me, what's the goal? The goal to find the value of? The goal is to find the value of x because we're solving the equations. So our goal is to find how much is going to be the value of x. Now what do you think? What's the next step? What's the operation here with parentheses with a log? What's the operation here?
Multiplying, so we got divide.
So no, before that, because we can divide because we have to separate the x's together. I have one x here and one x here. So I'm going to distribute here, distribute here. 3x log 2 minus 2 log 2. All right? Equal what? Can I do the same thing here? 2x log 3 plus 1 times log 3. Log 3. Okay, so far? The goal when I did this was I need to keep this one on this side because it has the x and that's the goal we need to find, and move this one to this side. And if you look here, it's just a number, this one. Because log 2, it's a number, times 2, a number. There is no variable like x. And that's our goal. The same thing here, log 3 is a number. So that's mean I'm going to move the x's on one side and the numbers by itself to the other side. So it's going to be what? 3x log 2, move everything here, minus 2x log 3. Okay? This one is a number, I'm going to move it to the other side. Equal, negative is going to be positive, plus log 3. I'm not going to care about here. This one is a number. Now, how I'm going to put the two x's together? I can't add it. I can't minus, because this is log 2, this is log 3. But can I take an x as a common factor between here and here?
We're gonna factor it out.
Yeah. Factor out the x. X, what's the left from this part? 3 log 2. Factor out the x, so minus 2 log 3. Okay. What's the operation between x and the parentheses? Multiplication. Equal what? 2 log 2 plus log 3. Now, how am I going to find the value of x? Tell me, how are you going to find the value of x? That's the step. If you have here
Gotta divide
Divide by what?
3 log 2 minus 2 log 3.
Like everything here. So after you divide everything here, x is going to be equal to log 2 plus log 3 divided by 3 log 2 minus 2 log 3. Can I cancel log 3 with log 3?
I don't think so because it has a 2 in front.
There is no 2. Can you cancel it? No. That's the question. You can't. Can you cancel if you have x minus y over 2x minus y? Can you cancel the y's? No, you can't because there's minus. Only if you have multiplication.
Okay.
Same thing here. I have plus minus. It doesn't mean I can cancel the log with the log. But if you have 3x over x, can you cancel the x? There's multiplication here. You get the idea? So the same thing. So in this case, only this part, you're going to plug in the calculator to find the value of x. This one is the exact solution. When you plug in, it's going to be approximate solution because you have to round the number. Okay? This is example 7. Example 8. First of all, how many terms do we have? 3 terms. Why it's called exponential equations? Because our variable as an exponent. So we can't solve it in the regular way like this because we have 3 terms. I have 3 terms, I'm going to think about factoring. Now, when you factoring, you're going to say, okay, that's what I learned to open 2 parentheses. Yes or no? E to the 2x. When you multiply same base, different exponents, how much the result? Let's make it easier. When you have x squared times x cubed, when you multiply 2 numbers, what are you going to do to the exponents? Add the exponents. It's going to be x to the power 5, not 6. You're going to add the exponents. When I have the same base, I'm going to add the exponents. When I have the same base, I'm going to do what to the exponents? Just add the exponents. So x plus x. Not the same thing here. So what's that mean? That means I can factor out the e to the 2x to ex. Is that okay? What about 12? 4, 2. Put minus. Now, negative 4 e to the x minus 2 to e to the x is going to be the middle term. You need to test. How are we going to test that? We're going to multiply these together, right? We're going to multiply these. Combine these together. It's going to be this term. No?
Okay.
You multiply.
It should be this. Have something wrong here? Right?
They're supposed to add up to it and then multiply to the.
So it's 6 and 2.
It should be 6 and 2, not 4. 6 and 2. Why I put 4 and 2?
Now it works out.
The 8.
No, why I put 4 and 2? I said 12. So now it's So this one is 6. So now it's 8. So negative 6 minus 2 is negative 8 on e to the x. So in this case, we didn't finish. We just factor it. That means this side is going to be what? The first one, e to the x minus 6 equals 0. Okay? The other side, e to the x minus 2 equals 0. Okay? Now, how are we going to solve? Don't look to the other one. How are we going to solve this one? Move the 6 to the other side. So it's going to be e to the x equal what? 6. How are we going to solve this one?
Gonna use the log method.
Log or the lane is the same thing. Can I check lane to the both sides? Lane 6. What happened to the log with the lane? So x equal what? Can I do the same thing with the other side? E to the x equal 2. Take ln. Cancel these. So how much the value of x? Okay. Every time when you have e, don't confuse yourself. Use the ln. Remember, because we say ln with the e is going to cancel out. There's not equal 1. How are you going to solve these?
Distribute.
Distribute what? Don't tell me you're going to distribute the log. You can't. Log is a function. This is the value of x. So log for this one. Log for this one. You got it? So don't say distribute. Now there's another rule. Remember when if we have log to x equal log to the y.
Yeah.
Can I say x equal y? So you can say this one equal this one. Come on. 5x minus 1 equal what? 2x plus 17. Can I solve this one? Minus 2x minus 2x. So 3x equal minus 1 equal 17. Move the 1. 3x equal what? And x equal 6. Now, every time we find the value of x, we have to do the value of x. We didn't do that before, but always you have to check your solution. If you plug in 6 here, 5 times 6, 30. Minus 1, 29. Log base 2 to the 29 is going to be fine. You're going to get a number. Plug in the 6 here, the same thing. 2 times 6, 12. 12 plus 17, 29. Is that the same thing we got here? So you're going to get 2 equal sides. Is that okay? So again, every time you have to check your solution. If you go to this example, can I do the same thing? Can I do the same thing here?
Yes.
Log. So I'm going to say x minus 7 equal what? 5 minus x. Move the x. I add an x. That means 2x minus 7 equal 5. Move the 5. That means 2x equal 12. And x equal what? 6. Now let's check. Plug in the 6 here. Log 6 minus 7 equal what? Go ahead. Plug in this one in the calculator. Plug in the 6 here. 6 minus 7 is negative 1. So when you plug in log to the negative 1, how much is going to be? The result here, plug in 6 here. 6 minus 7 is negative 1. I'm sure log to the negative number is going to be undefined. That's why this one is not going to be a solution. Okay? We don't care about the other side because it's undefined. When you plug in here, 5 minus 6 is also a negative number. It's going to be undefined, but it doesn't mean they are equal. This is undefined, this is undefined. It doesn't mean they are equal. Okay? Now, how are we gonna solve this? Have ln parentheses. Our goal is to find the value of x. But I have ln natural log parentheses plus another natural log with x equal natural log. The 10. I'm gonna solve this one. Think about that, lad. Okay. We learned and told you the problem with this section, we learn a lot of rules. How are we gonna put all these rules together? Every time I need one of these rules, I can use it. Look to the left side. What do we have on the left side? We have 2 ln. Can I use this rule? When I have ln x equal ln y, that's mean x equal y. I can't use it because I have 2 ln function on the left side. How I'm gonna make these 2 ln functions as a 1? There's a way. We learn this way.
You put the x added to the other one.
How?
Guess you could factor it.
No, it's already factored. There is a rule. We use it a lot. When I have 2 ln,
Put it together, in other words.
how? How are we gonna put these together?
Then times x plus 3, then times x.
That's right. But which rule this one? Got it.
Yeah, for that.
Remember, when we have ln xy equal ln x plus ln y, you have this rule, the properties. I have this side, and I bring it back as a multiplication. And how many ln? 1. So I'm going to do the same thing with this side. I can say ln, this is x and this is the y. I can put it together as ln x plus 3 times x equal what? 10. That was the next step. You can distribute, you can fold, it doesn't matter. Now, can I use this property, the 1-to-1 property? If you have ln x equal ln y, that means x equal. Where is x? Everything here. X plus 3 times x equal 10. Now this one is easier to solve. Distribute x squared plus 3x equal 10. Now x squared plus 3x minus 10 equal 0. What's the next step? The factor. Ten x 5 2 positive negative. Is that okay? Because we need to get positive 3. That's mean x equal -5 and x equal 2. What's the next step?
Plug it in.
Plug in. So when x equal 5, plug in -5. Sorry, x equal -5. Plug in -5 here. -5 plus 3, -2. Link to the negative number and define. That's it. I don't have to keep going with the -5 because it's undefined. Plug in the 2. Link 5 because 2 plus 3 5 plus link 2 is going to be equal size. You have to check if this one is a solution by getting 2 equal sides. Okay. So number 11, solve log x minus 4 minus log x plus 1 equal what? The rule says rule says the properties, if we have log x over y or len, it's going to be log x minus log y, right? Now I have this side, I have log minus log, log x minus log y. I need to bring it back as what? As one log to the fraction. If I need to bring this side is what? Log 1 over 3x minus 4 divided by what? X plus 1. Is that okay? Or no? Got it? Sure.
Oh, yeah, I'm just thinking.
The properties. In the beginning of this section, we learn these properties. Now, where is the other side? Log 2. Now, log x equal log y. Can I say x equal y? 3x minus 4 over x plus 1 equal 2. Sometimes what you're doing, I have log on both sides. Kind of you saying, okay, I'm going to cancel these. Okay? It's the same thing. But in fact, it's not canceling. It's a property. When I have log x equal log y, that means x equal 1. Okay? Now, how am I going to solve this one? Multiply by
Plus 1.
So 3x minus 4, x plus 1 times x plus 1 equal 2 times x plus 1. Cancel. X plus 2. I'm not going to do the rest.
You're going to subtract 2x.
Yeah, just move the variable to one side, the numbers to the other side, and solve it. Is that okay? Which properties I can use?
You're going to put the 2 on top of the x.
Yes. So every time when I have number here, it means it's an exponent. So on this side, I can say, okay, it's log base 3x squared. There is the equal sign. What about the right side? If I have a plus between two log, does that mean what? Multiplication. So it's log 2 times what? 3x minus 4. Is that okay? The base. Yes or no? Now what's the next step? Kind of. Can you cancel this log with this log? It's using the property log x equal log y. That means x equal y. So kind of to make it easy, okay, I can cancel it by saying x equal 2 3x minus 4. Now this is easier to work on. Distribute x squared equals 6x minus 8. Move everything to this side. X squared minus 6x plus 8 equal 0. Okay. Now next step. Factoring. You can say x 8 4 2 minus. Is that okay? Next step. X minus 4 equals 0. That means x equal 4. X minus 2 equals 0. That means x equal 2. You have to check both these solutions because the problem is going to be here. Because every time when I have log to negative number, it's going to be a problem. So check 4, plug in 4 here, plug in 4 here. You have to get 2 equal sides. Plug in 2 here, you'll be fine here. Plug in 2 here and check if you get 2 equal sides. Remember when we have to convert, because here's the thing, I can't use one of these properties It says log x equal log y, that's mean x equal y, because I don't have a log here, I just have a number. But remember when we took how to convert from the logarithm form to the exponential form? I think the second section,
Oh, yeah.
remember when we moved the base from here to the other side and cancel the log? So when I move the base to the other side, it's going to be 5 squared equal, on this side is what's the left? Come on, that's it.
I forgot about that.
You see? How many steps? 1. This is 25. Equal 3x plus 1. Move. 3x is going to be equal to 24. Divide by 3. X equal. And if you plug in 8 here in the calculator, how much are you going to get? So here is the other side. Can I do the same thing with this example? Minus between, I'm not going to care about here because it's here, it's just a number. Minus between 2 log. What does that mean? That means it's division, right? So it's going to be log this one divided by this one. So it's going to be log, so the base of 3, x plus 6 divided by equal 2. Now what's the next step? I have log on one side. That's been the same thing we did here. I'm just gonna move the base here, convert it from the logarithm form to the exponential form. So by moving the base, we're gonna get x plus 6 over x minus 2 equal 3 squared. Which is mean x plus 6, x minus 2 equal 3 squared, which is 9. Then I'm going to solve the rational equations by multiplying by the least common denominator. Left here, x plus 6 equal 9, x minus 2. X plus 6 equal 9x minus 18. Keep doing the rest. So linear equations, move the variable to one side and the number to the other side, then find the value of x. And always check your solution. Go with this one.
The other one.
So this one.
What?
So this one.
Then you
That's what we're talking about, like you add.
add a log x.
Yes, because you see, I have log on this side, I have log on this side, but there is a number. That's the problem. So I can't say log x equal log y, that's mean x equal y, but that's the problem. But can I move this log to this side? Yes. So we're gonna add log x, add log x. This one is gonna be 0, but it doesn't mean you're gonna add the logs. It's gonna be log x plus 15 plus what? Log x equal to. Now, plus between 2 log, what does that mean? Multiplication. So it will be log, I'm gonna put it like this, x plus 15 times x equal to. Check, do we have base? No, the one you have in the. No. Okay,
Has a 10 if it's a
10. I'm trying to make sure that there's a number here. If there is no base, that means how much the base? 10. So now distribute here. Log is going to be what? X squared plus 15x equal to. Now there is no base, it's mean 10. So I'm going to move the base to the other side to convert it from the log form to the exponential form. Equal 10 squared. 10 squared is the x squared plus 15x minus 100 equals 0. Now, how are we going to factor this one? Come on, should be faster.
Can you break it up to x squared plus 5x plus 10x minus 100?
Which one?
I don't know.
Square, just factor it.
20 and 5.
20 and 5, that's it.
Yeah, I'm over here trying to like,
How
how do you divide 100 by 15? But yeah, that makes sense.
Yeah, so just open two parentheses. And
We're breaking my head.
just overthink it. XX. And you say 20 and 5. How much you gonna put? Because it's supposed to be positive. That's it. Equals 0. Keep the rest. Okay. What about next one? Next example. How are we gonna solve it?
Can you,
The same way, but with this example, you have to do two moves. Move the log to this side, and you have to move the 3 to the other side. Which one you want to start first? Let's add 3. Cancel here. So what's will be log 4 x squared minus 9 equal log 4 x plus 3 plus 3. Be careful, this is 3 by itself, not belong to the log. Then you're gonna say minus log 4 x plus 3 from both sides. From this side, so here is going to be log 4 x squared minus 9 minus log 4 x plus 3 equals 3. Now, which example is similar to this one? The same way we did there. When I have minus between two log is going to be what? X squared minus 9 divided by x plus 3 equals 3. It's exactly what we did over there. Then move this one here and solve the rest. You get the idea? So for example, 18. Let's read 18.
If $20,000 is invested,
Wait, so it's invested. How many? 20,000. So A equal 20,000. Okay, keep going.
an account earning 2.5 interest compounded continuously.
Yes. So it's interest rate equal 2.5. 2.5%, which is equal, remember that? 2.5 divided by 100.
Determine how long it will take.
How long? What does that mean?
Of the future value?
No, determine how long,
Oh, how much time?
how much time. So the time, that's what we need to find. Determine how long it will take the money to grow to.
45,000.
So this one is the future. There is something wrong. Because this one is the E. And the future value A equal 45,000. Now 2.5 divided by 100. Don't be what?
0.025.
0.025. So this is the interest. Come on, check how many. If you 20,000, they're gonna give you interest like this. This is a real problem. That's what they're gonna offer you. How long it takes, and you will see how long it takes to grow your money from 20,000 to 45. Let's see how many. I don't know, maybe 10 years. What do you think? 10 years? Like, just guess.
Man, it's gonna take like 30 or 40.
If you put this one in your bank and they're gonna give you interest 0.025, your money is going to be 45,000. But we see like how long?
100.
10 years? I don't think it's not 10 years. 20. And you said, Carlos, like maybe 40 years, maybe. Let's see.
We're gonna use the APER.
They already gave you the formula, right? They're telling you because it's continuously. That means the formula we have to use is compound continuity. That means A equals PERT. This is the formula we have to use. Let's write down here again. PERT. Let's plug in. How much the future value? 4530 equal. The invest 40,000. E, the rate is. Here is the time we need to find. How are we going to solve this one? How are we going to solve this one? What's the first step we have to do?
We gotta turn it. We gotta add the lid.
No, but before that,
We gotta multiply the time.
no. We need to find the time.
Okay, the time.
I have a number here times E. The problem here, because there is a variable here. How I'm gonna cancel this number? Divided by 20. So divide both sides by 20,000. Cancel here. 45,000 divided by 9/4. Equal E 0.025 T. Is that okay so far? I just simplified. Cancel 3 zeros with the 3 zeros. 45 divided by 5, 9. 20 by 5, 4. I can't simplify it anymore. If you put the decimal number after you dividing these two numbers, it's still the same answer, okay? The same solution. And what's the next step?
Use the length.
Now we're gonna take the length of both sides. If you check the previous examples, we never get an example to find the time. Because we have to learn to use the length before we do this problem if we need to find the time. So now with this problem, if you take the length to the both sides, this cancel, what left? Length 9/4 equal 0.025 T. Now how are we gonna find the time? Just divide both sides by we have here. So I'm going to divide this one by 0.025. Divide this one by 0.025. That means the time is going to be equal. Length 9/4. Everything divided by 0.025. Check how much it's going to be. Around 30 years. Go ahead and plug in. I don't know. Around 30 years. 35. So 32 years. 32 point something? Can we say 33?
32.437.
Let's do it 33. So if you invest your money in a bank, you invested 20,000 with 50% of the rate, and the future value is going to be 45 after how many years? It's worth it.